Number 7, prove that the sum of the squares of any two consecutive integers is an odd number. So basically, if we think about two consecutive integers, consecutive means next to each other. So if we think of the first value as n, and then the next one as n plus 1, okay, because that would be the one after it, wouldn't it? So we've got consecutive integers. Now the sum of the squares of these, okay, so we need to square them. So that will be n squared when I square it. And that will be n plus 1 all squared, yeah? When I square that, you've got to square the whole thing together, yeah? And then it says the sum of them, so I need to add it, okay? So when I add it then, I've got that. And then, of course, this becomes n squared. This, of course, is a bracket n plus 1, n plus 1. So if I multiply this out, okay, I get n squared. Do the first in here, that's n squared. Do the outers, it'll be n. Do the inners, that'll be n. And do the last, that'll be 1. Okay, so then I get 2n squared plus 2n plus 1. And as we saw earlier, we can, you notice here there's a common factor of 2. So we can take out 2 and we can say n squared plus n. I'm only taking out 2 to show that this then is even, yeah? When I factorize this, take out 2 and it's even. And of course then we've got that plus 1. So we know this is even because it's a multiple of 2, and then we're going to add 1. So this is even. Add an odd number, and that will equal odd. Okay, so therefore it's always going to be odd.